As the operator of one of Australia's largest freight rail networks, the Australian Rail Track Corporation continues to drive innovation in rail. The Advanced Train Management System, or ATMS, has been custom engineered for Australian conditions by ARTC alongside its technology partner Lockheed Martin. ATMS is a digital train management solution with real-time monitoring of trains with GPS and mobile technology, making trains smart. With a simplified train control and network operating system, ATMS is easier and more efficient for train drivers and network controllers to use, delivers fast safety improvements, and reduces operational and maintenance costs. Before moving into ATMS territory, the train establishes communication with the network control center. The driver enters the train data through the driver display screen, including train ID, length, and weight. The driver-machine interface provides the connection between the driver, the train, and the network control center. It's a touchscreen device positioned in the driver console of the locomotive, providing the driver with information regarding the train's movement authority, target speed, current speed, and other geographical and track features, as well as an enhancing situational awareness of upcoming work sites or changes in network conditions. The train's data is sent to network control electronically without any verbal communication required. ATMS uses existing 3G and 4G communications and has been designed to work with future networks. An alert signals to the network controller the train is awaiting authority to proceed, who then communicates authority to the train. On receiving authority from network control, the driver can then proceed into ATMS territory, seen here moving through Spencer Junction in Port Augusta, South Australia. ATMS introduces a range of features that enhance the safety, efficiency, and productivity of Australian rail operations. The ATMS train-borne system in the train's cabin is equipped with a power switch, which has 3 positions: off, start bypass, and run. The start bypass position enables the driver to log in their details, and the run position enables the train's enforcement capabilities. In approaching an unsafe situation and the train's brakes need to be enforced, the power switch must be in the run position. If the driver moves the switch from the run position while on territory, a safety alarm will be displayed on the network controller's screen. One of the many benefits of ATMS is increased network capacity by enabling trains to operate closer together. When 2 or more trains are travelling in the same direction, this is referred to as fleeting. ATMS technology is based on virtual moving blocks, meaning train separation isn't constrained by the traditional physical fixed blocks or a single train occupying a section at any time. ATMS uses much smaller electronic blocks that enable several trains to move at 4-minute intervals. This technology effectively increases the capacity of ARTC's network. The train driver can see the train ahead on the screen, represented by a brown line, as well as its ID number. It provides the driver with a 10-kilometre forward view of the track route. The blue vertical line represents the train and its position in relation to the kilometre pegs. This fleeting of trains allows for superior efficiency, especially when compared with the current practice. Train crews are advised of speed restrictions and warned of approaching speed limit changes or track work locations. When a train is within 10 kilometres of a temporary speed restriction, a yellow braking curve followed by an alert will appear on the driver's screen. The train-borne equipment will provide a warning to the driver if they are not slowing in time or if they increase speed while traversing the restriction. If the train is going too fast on approach to a speed restriction or the limit of their authority, the system displays a visual yellow warning followed by an audible alert. If the driver fails to acknowledge and slow down, the system will then enforce the train's brakes, bringing the train to a complete safe stop. At the same time, the network controller will receive an alert on their train control system, advising there has been an enforcement on the network. The trackside infrastructure is in constant communications with the authority management server in the network control center. If communications fail, an alert will appear on the driver's screen, warning them that the ATMS can't confirm the route in front of it. The driver then must verify that the condition is safe to proceed and provide confirmation to the train-borne system before they can proceed. If a track worker has an authority in the vicinity, it will be displayed on the driver's screen with a blue line labelled BPA, Blocking Protection Authority, as seen here on the Rapina crossing loop, providing the driver with full situational awareness. At the end of the section and when exiting ATMS territory, the system will protect the boundary until the driver has confirmed they have authority to enter the adjacent safe working territory. ATMS will not permit the train to exit until the driver provides confirmation by pressing the ATMS Secure button. Without that acknowledgement, ATMS will bring the train to a stop before the ATMS territory boundary. Alongside an increase in safety, ATMS will also improve network reliability and resilience, ensuring our customers run on time and safely. As we deploy this innovative solution on a larger scale, it will increase the productivity of Australia's freight rail network and further build rail's role as the mode of choice in the national logistics chain.